We're going to start with the first two methods, primarily long division today. We're going to focus on that because long division is this catch-all that works with everything. Tomorrow we'll talk about synthetic division. There's a lot of similarities, but it's a shortcut method that we apply to a lot of higher level algebra theorems. And so it allows us that shortcut so we can save time on the division part and focus on the other pieces of information that we want to gain. But we still need to be able to do our long division. Okay? So there's three types of polynomials that we'll be dividing by that will determine what we have for our division. So first, we're going to be dividing by a monomial. What does it mean if I have a monomial? One term. Okay? So look very carefully at that. It's one term. How do I distinguish whether I have one term or more than one term? What symbol am I looking for? What distinguishes one term from another term? Adding and subtracting. So my denominator has no adding or subtracting. It's one term. I'm dividing by a monomial. And my numerator will be multiple terms. It could be 2, 3, 4, 5. What we're doing when we're dividing by a monomial is we're actually undoing the addition and subtraction that we've been doing. We take each term in the numerator and write it as its own fraction with that same common denominator. Take each term in the numerator and write it as its own fraction with that common denominator. And then I just simplify each of those fractions. We are undoing the addition and subtraction that we've been doing. It's the reverse of it. Okay? So if I have two terms in my numerator, I'm going to have two fractions. If I have three terms in my numerator, I'll have three fractions. 4 terms, 4 fractions. And then simplify each one as appropriate. So I've got this polynomial, negative 12x to the third, plus 36a minus 15, and I want to divide it by 3a. So I can go ahead and write it as a fraction, as a rational expression, because division is fractions, fractions are division. So how many terms do I have in my numerator? 3. Do I have only one term in my denominator? Yes, so that means I'm dividing by the monomial. So 3 terms in the numerator means I'm going to have 3 fractions. I'll start with negative 12a to the third over 3a. First term over the denominator. What's the numerator of my second fraction going to be? 36a over that same common denominator. Since 36 is positive, we're doing plus. What about the third fraction? Yeah, so I'll do minus 15, again, over that common denominator. And then just simplify each one. Negative 12 divided by 3. Negative 4, a to the third divided by a squared. Okay? 36 divided by 3. A divided by a. 1. So that cancels out. 15 divided by 3. 5. I don't have anything in the numerator for the a to simplify with, so that a stays in the denominator. Or is a separate fraction with the same denominator. Simplified each one. So 12 divided by 3, negative 4. Simplify the a's. 36 divided by 3. Simplify the a's. Here, I can simplify the 15 over 3, but that a has nothing to simplify with in the numerator, so the a has to stay in the denominator. Okay? How many fractions am I going to have for the second one? 3. What are they going to be? Okay? 10 over 5. 2. T to the 4th divided by t squared. 35 divided by 5. t to the third divided by t squared. 5 divided by 5. T squared divided by t squared. Not so bad, right? So again, we're just dividing it. We're simplifying. Okay. That's if you're dividing by a monomial. Okay. Monomial only. If it's not a monomial, then we're going to be using long division. Okay. So, dividing a polynomial by a polynomial that is not a monomial uses the long division technique. It is very similar to our standard division algorithm. Now, I know different countries, their standard division algorithm varies a little bit from ours in the United States. So that is based on this, but I'm going to walk you through the steps. Okay? So I want to divide 7,256 divided by 43. I'm dividing that 1,000 number by 43. First step is that I say, okay, well, how many times does 43 go into 72? Well, it only goes in once. Second step is to multiply that 1 by the 43 and set it under the 72, and I'm going to go ahead and then subtract to get 29. And then I bring down the next number, and I continue the process. Divide, multiply, subtract, bring down. But instead of worrying about this number, now I'm worried about this number. How many times does 43 go into 295? It goes in 6 times. I multiply, and I get 258, and then I subtract to get what's left over. I bring down the 6, and then I repeat the process again. So here I repeat, here I repeat, but now I'm done worried about that number, and now I'm worried about this one. How many times does 43 go into 376? 8 times. Multiply, subtract, and then there's nothing to bring down, so I'm done. And that's my remainder. Okay? And so my remainder, when I have a remainder, the way it's written is I've got my quotient, remainder over the divisor. We're going to be using a similar pattern with our polynomial division if we get a remainder. Okay? But the thing to focus on is this is the exact same process we're going to be using. Step 1, we're going to divide. Then we're going to multiply. Then we're going to subtract. Then we're going to bring down. And we're going to rinse and repeat until I can't do that division step anymore. Okay? Divide, multiply, subtract, bring down. Okay? Now, so I've got my division set up. I always look at, okay, so I'm starting at the beginning. I'm going to divide 28x squared, but I'm not going to divide it by the entire thing. I'm only dividing it by the 7x. All of the division steps will be with 7x. Okay? The multiply steps will include both, but the division step only will include 7x. Okay? So I'm going to divide 28x squared by 7x. And what does that give me as my quotient? Close. 4x. Okay? Now, that gives me 4x. The other big thing with long division is neatness and organization is really important. Okay? More than anything else that we do in math, it's really important for here because it's really easy to get things off skew and then you get lost and it's just, you got to start over and then you cry. Okay? So what we do is we keep all of our like terms in line. So if I end up with a 4x, it goes in the linear column up here. Okay? Keep it in line. And it's going to happen too when I multiply and I put numbers underneath it. I'm going to keep it in line with the matching powers. Okay? So that was step 1, was divide. Step 2 is to, let's get to the next part, multiply. I'm multiplying 4x by the entire divisor. Okay? I'm multiplying 4x by the entire divisor. What is 4x times 7x? 28x squared. these should always match. These should always match. 4x times 3. 12x. Okay? These may or may not match. Most of the time they won't. Sometimes they do. Okay? But that first term should always match because now our next step is to subtract. Okay? So I'm going to take 28x squared minus 23x and I'm going to subtract 28x squared plus 12x. Alright, well if I do 28 minus 28, what do I get? 0. That cancels out. That's our goal there. Negative 23 minus 12. That will be the most common mistake. And I'm actually really glad you said that. Negative 35. We are not combining like terms. We are subtracting. And that's really important that you take your time on that step because that will be the single most common mistake that is made. Subtract negative 23 minus 12, negative 35x. Okay. Next step is to bring down. We're going to bring down the negative 15. Okay, bring down the negative 15. And then we repeat the process. We're going to divide again. Okay? But now I'm not focused on this polynomial anymore. I'm focused on this one. So what do we think we're going to divide now? I'm going to divide by 7x, but what's getting divided by 7x? Negative 35x. Negative 35x will be divided by 7x, which gives me a quotient of what? Close. Negative 5. And then we go to multiply. What am I multiplying? Good. So what up here gets multiplied by our divisor. So negative 5 times 7x plus 3. All right, which gives me negative 35x minus 15. Okay? And then we subtract. Okay? So negative 35x minus 15 minus negative 35x minus 15. So negative 35 minus negative 35 gives me what? Negative 35 minus negative 35. 0. When you subtract a negative, what does it become? So you're adding. Negative 35 plus 35 is 0. Negative 15 minus negative 15. 0. So we end up with no remainder. So my answer is just my quotient. That's my answer. Quotient is 4x minus 5. And that's it. Divide, multiply, subtract, bring down, repeat. There's nothing to bring down there, so we're done. Okay? Let's do it again. First step. 4x squared divided by 2x. It gives me what? 2x. Where am I going to put that 2x? Above the negative 6. Good. Step 2. Good. Multiply. 2x times 2x. 4x squared. 2x times 7. Step 3. Good. 4x minus 4x. Negative 6 minus 14. Negative 20. Step 4. Bring down. And then we repeat. Step 1 again. Gives me what? negative 10. Okay? Step 2 again. No, we're going to multiply. Okay? Step 3 again. Subtract. Negative 20 minus negative 20. 0. 8 minus negative 70. 78. Is there anything left to break down? If I divide 78 by 2x, will I still have an x in the denominator? Yes, so then I stop. If I do 78 divided by 2x, that gives me, leaves an x in the denominator. I stop. Okay? That is my remainder. Okay? That's my remainder. I can't do that division and get a non-rational outcome. So that's my remainder. Here's how we write it, this format. Similar to with our mixed numbers. Mixed numbers are quotient plus remainder over divisor. That's how mixed numbers are written. So we're doing the same thing with polynomials. Is I'm taking the quotient, which is 2x minus 10, and then I'm adding it to my remainder over the divisor, which is 2x plus 7. Might skip this one. Hold, please. Yeah, I'm going to skip this one because I added another question at the end and I'd rather have more time to do that. All right. So I need to set up the division. I'm dividing my first polynomial by the second one. So which polynomial is going to go on the outside of the division? Y minus 2. Okay. What's going to go on the inside? Good, except, how is that one different from everything we've gotten so far? It's in the wrong order. We need to put it in standard form. So standard form means which term is going to come first? Y squared. And then after that, negative 5y and plus 6. Has to be in standard form. If you don't write it in order of descending powers, you're going to mess up the whole thing. Okay? It's like trying to do long division and dividing by the tens place before you do the hundredth place or the thousandth place. You can't do it out of order. So we need to make sure we write it in order of descending powers. And then we start our process. So what am I going to divide to start? Y squared divided by y gives me what? Y. Where am I going to put it? Over the 5. And then, step 2. What else? There you go. And then we're going to subtract that. Y squared minus y squared. 0. Negative 5 minus negative 2. Negative 3y. Negative 5 minus negative 2. That means I'm adding 2. Negative 5 plus 2. Negative 3y. Change the color on that. And now what?
Plus 6.
Plus 6. Bring down the 6. Okay? Now what's my next division step? 3y divided by y gives me negative 3. Then we multiply. Multiply again. Last step. Subtract. No remainder. My quotient is y minus 3. So, I need standard form again. Do I have standard form? No, what's out of order? 7x to the third and the negative 1, right? So I need to put those in the right place, but I still have my divisor, which is 7x to the third plus 16x squared plus 2x minus 1. So again, making sure you get it in standard form, and then go through the process. Step 1, divide. 7x to the third divided by x, 7x squared. Step 2, multiply. 7x squared times x plus 4, 7x to the third plus 28x squared, 8 squared. Step 3, subtract. That cancels. 16 minus 28, negative 12. Step 4, bring down the 2x. Okay? And then repeat. Do it again. Negative 12x squared divided by x gives me what? Keep going. Multiply negative 12x by x plus 4. What does that give me? Minus 48. Step 3. We'll print another one after we subtract. So negative 12 minus negative 12 cancels out. 2x minus negative 48x. 50. 50x. I told you guys that subtraction will mess you up the most. Okay? Bring down the negative 1. Now what? What's 50x divided by x? And then we multiply. Get 50x plus 200. Last step. Okay? 50x divided by, or 50x minus 50x. 0. Negative 1 minus 200. Okay? Anything else? No, that's it. I can't do that and get rid of that x in the denominator. So that's my remainder. So how do I write my quotient out? There you go. Yeah, you can multiply. It's not going to be easy. I mean, it is easy. It's not going to be cool. So the best thing to do is just kind of run through and double check your multiplication, double check your subtraction, because those are the two places where I see the most mistakes, is the multiplication. But yes, because we're doing division, if I wanted to undo it, I could take this and multiply it by x plus 4. And so you're going to do this, 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 this. And because we have this, it gets ugly. You can do it. If we don't have a remainder, back checking it is a lot easier, because then we can just multiply and we should get back to our original dividend. But if we've got a remainder, it just becomes a little bit longer of a process. You can do it, but I recommend just double checking your multiplication is correct and making sure that you're actually doing subtraction. Okay, that's where I see the most mistakes. Okay? All right. Do our division again. I've got 3x plus 2 on the outside. 3x plus 2. There we go. How is this dividend different from the rest we've seen so far? It only has 2 terms. Okay? If I asked you to divide 2008 by 2, and you wrote it like this, would you get the same answer?
No.
No. Your exponents are like the place values of an integer. If I'm missing the exponents, I need to fill in placeholder zeros for those place values. So I'm not going to have just 27x to the third plus 8. I also need to make sure that I include a placeholder 0 for the x squared and another placeholder 0 for the x. And then I can put in the constant. I need to put in placeholder zeros because I don't have a squared term and I don't have a linear term. I only have a cubic and I have a constant, but I'm missing the two terms in the middle. So I have to put a placeholder 0, and you'll see in a second why. Okay, so let's start the process. We do division first, right? 27x to the third divided by 3x gives me what? 9x squared. So that's going to go above my 0x squared. 9x squared times 3x plus 2 gives me 27x to the third plus 18x squared. You see why we have to have that placeholder 0? I need something to subtract from. And since there's no squared term in my original, I have to have the placeholder so I have something for the subtraction. So first term cancels. What's 0 minus 18? Negative 18. And then I bring down the 0x. Okay? And then repeat the process. Negative 18x squared divided by 3x. Negative 6x. I multiply. And then again, I needed that 0x because I need something for the subtraction. That cancels. 0 minus negative 12. Positive 12. And then we bring down the 8. And we do it one last time. 12x divided by 3x. 12x divided by 3x. Multiply. Subtract. No remainder. So our quotient is 9x squared minus 6x plus 4. Okay? And then Beatrice, to answer your question from earlier, if I wanted to take this, 9x squared plus 6, or 9x squared minus 6x plus 4, and I multiply it by 3x plus 2, I should end up back here at 27x to the third plus 8. Okay. Also note, 27x to the third plus 8 is a sum of cubes. Its factors are 3x plus 2 and 9x squared minus 6x plus 4. That'll become very important later on. That'll become very important. These are the factors of that. One more. All right. Remember, I skipped one, so I'm adding this one in. What do you notice about the divisor? I mean, it's up to you. Your notes. So the dividend, this is the dividend. The big one's the dividend. It's in standard form, so we're good. We got extra fifth power. What do we notice about the divisor? That's squared. Same process, though. I want to show it because it throws a lot of people off the first time that they see it. So we still set it up in the same manner. It's just going to we're going to stop sooner when we get to the remainder. Okay? So 3x to the fifth minus x to the third plus 4x squared minus 12x minus 8. Now, I just pulled this out of the textbook, so I have no idea what the answer is going to be. So let's do it. All right, first step, what am I going to divide? Harris? Okay, yep. I do. For which one? Yes, thank you. I absolutely do need that placeholder 0. Thank you very much for catching that. Told you, I literally just pulled this out of the textbook. I have not verified this yet.
Why do you know one, third, fourth one?
I have fifth, fourth, third, second, first, none. The only one I'm missing is fourth power, so that's the only one I need to put in. Thank you for that. Okay? There we go. First step, division. What am I dividing? Yep. So 3x to the fifth divided by x squared gives me what? 3x to the third. So I'm going to put it right here. 3x to the third. Okay? 3x to the third times x squared minus 6. I'm sorry, x squared minus 2. I can read numbers. Multiply. Same thing that we always do. What's up here by the divisor? 3x to the fifth. And then, what did you say? Negative 6x cubed. Okay? Now, sometimes we don't end up with anything there. It happens. I can just skip over it. Where did I lose you? Multiply this by this. That's where I get this and this. But I want to line up the powers. Because I can't subtract negative 6x to the third from 0x to the fourth. They're not the same power. So I need to line it up. Okay, so keep everything in line. So I do my subtraction. Okay, 3x to the fifth minus 3x to the fifth. That cancels out. 0 minus 0, still 0. So now I don't need it anymore, but we need it just in case. Now I can go to the negative x to the third minus negative 6x to the third. Negative 1 minus negative 6. And then bring down, and we repeat. What's the next division? Good. 5x to the third divided by x squared gives me, oopsies, spot. Above the x term. Put it above the x term. And then we multiply again. 5x times x squared. 5x to the third. 5x times negative 2. Negative 10x. I'm not going to put it underneath the squared. So now I need to also bring down this negative 12x so that I can do the subtraction. So we're bringing down what we need for our subtraction. I can do my division here, or my subtraction here. That cancels out. 4 minus nothing. 4. Negative 12 minus negative 10. And then we'll bring down the negative 8. Okay? What's our next division? 4x squared divided by x squared gives me what? Plus 4. Multiply. 8. Okay? Subtract. That cancels. Negative 2 minus nothing. Negative 8 minus 8. Negative 16. That, negative 2x, has a power lower than that. That means it's done. That's the remainder. So once the power of what's left over is lower than your divisor, you're done. Because if I do negative 2x divided by x squared, I still have an x in the denominator. Okay? I only want, I don't want any fractions in my quotient up at the top. So we're going to write our final answer. My quotient is 3x squared plus 5x plus 4 plus negative 2x minus 16 over x squared minus 2.